Hi there, welcome back to the next video. And in this video, as you can see, we will going to look at Qlik's correl or correlation function that is available in both chart and script. So correlation is basically a statistical function which helps understand how two numerical variables are related. So they basically show, or this function basically show their strength. So it ranges from -1 to +1, where -1 say perfectly negative correlation. That means those two things goes in a different direction. And that's for example, if you see at the places where you have a huge presence of winter season, you will not see a lot of clothes which you usually wear in the summer. So in that case, it will be like perfectly negative correlated, where nobody is buying the summer clothes over there, but mostly the winter clothes. And that second condition, buying mostly the winter clothes, is basically the perfectly positive correlation, where two different variables goes together with the data or with the trend. So from -1 to +1, like I said, -1 negatively correlated, +1 positively correlated, but 0 is also a part of this interval or this entire measurement, where 0 indicate that no correlation at all. Alright, so now let's go ahead and see the data and implement the correlation. So if you see, this is a salary data, and you have employee name, gender, age, and salary. And we will try to figure out the correlation between age and salary. That means if the age is increasing, whether the salary is increasing, then it is a positive correlation. And if the age is increasing and salary is not increasing, then it is a negative correlation. All right. So for that, what we can do is we can create a correl table, or we can say correlation table, whatever we want, not an issue. So we will say load, and we want to see, let's say, by gender, right? So load gender, comma, correl, and in that we will specify age and salary. Doesn't really have any issue if you have salary first or age first. You can have any parameter, because at the end of the day it will going to tell us the age salary correlation. So let's make it age sal correl, the name of the column of this correl function, right? The output that it will going to give will be recorded in the age cell correl. Resident of salary, because from here, from this salary table, we are fetching gender, which is here. We are fetching age and salary, which is here and here. And then group by, because we have a dimension gender and an aggregation function used, which is a correlation. All right, so that's about it. Let's hit save. Let's load data. It's done. Come to analysis. In the correl, this is basically we will see with a table, and over here we will select the dimension gender, because by gender we have taken the correlation, and add one more dimension, because we have already calculated age cell correl, so no need to do this again and now measure. And now we can see that in case of a female, it's very close to perfect correlation, which is 0.96. that is very close to 1. So it shows that in case of female gender, you have a near to perfect positive correlation, and in case of male also somehow similar but less than female, you have a positive correlation. So that basically indicates that in case of a female, it is highly likely that when the age is increasing, the salary is also increasing. But in case of a male, based on this data, it is less likely. So this is basically the interpretation that one can make. After that, we can add one more measure over here, and let's go in the expression editor, specify correl function. This time let's take salary first, because as I mentioned, there is no issue. if you take salary or age, in any order of precedence. So again, you will see that female, when we calculate it in the front end, is the same output. In case of a male, it's the same output, and the overall correlation of the entire data is 0.9270, which is very close to perfectly positive correlation. But as you can see, the 0.91 and 96, it is coming somewhere in between, like 0.927 or 0.93 is the overall correlation value. But that's about how you can calculate the backend and front end correlation. And the benefit of calculating in the backend, let's say you would not like, or you basically need a static table which is not changing, then you can have this correlation as part of the backend calculation. But if something you want correlation to be changed based on the selections, based on some dynamic changes you want, you can put it in the front end. And a small downside of this is that Qlik engine will have to calculate again and again based on the selection you are making. So that will have an impact on on the performance of the application. If the data set is huge or there are a lot of calculation, that will slow down the performance. But in this case, since it is just displaying it based on the dimension on which you have calculated it, it will not have a severe impact. So take the logical balance and go ahead with that. But that's about how you can calculate the correlation within Qlik Sense.